Welcome everyone to our first ever Concrete Masonry Programs Wednesday webinar. So thank you everyone for joining us today. My name is Alicia Hodges and I'm the Concrete Masonry Checkoff Program Director. And as we begin to lift our programs off the ground, which is really awesome, we will routinely host webinars about our program. So you will see one every month. Typically at the end of the month on a Wednesday, and for next month we will have Clutch host our Wednesday webinar, and they will officially unveil our new branding to everybody. So, but for today, we do have Phil Ledent joining us. So welcome to Phil. Phil is with the Masonry Institute of Michigan. So hello, Phil. How are you today?
I am good. Thanks for having me, Alicia.
Awesome, you bet. And we have Erin Heidecker from Clutch. She's a program director at Clutch. So Erin, thank you for joining us.
Thanks everyone for joining.
Yeah, and Erin is here to offer technical support in case anything goes crazy for us. So just as an FYI, guys, like I said, we are in a webinar format, so your cameras are off, your microphones are muted. But we do want you to stay engaged in the webinar. And so if you have questions, please put those into the Q&A, and Phil will answer those along the way. So with that, I'm going to share a little bit about Phil. So Phil Ledent, PE and SE, is the Executive Director of the Masonry Institute of Michigan and an adjunct professor at Lawrence Technological University, where he teaches structural masonry design, and he previously taught at the University of Toledo. Prior to joining the MIM, he managed the structural engineering department at Bergman Associates in Lansing, Michigan, and worked as a senior structural engineer at Fishbeck. He is the secretary of the TMS 402-602-28 main committee and an at-large member of the TMS board of directors. He is a voting member on ASTM Committee C12 mortars and grouts for unit masonry and C15 manufactured masonry units. And Phil has 4 checkoff programs, and he has agreed, he has volunteered to share about those programs with you today, and we're excited to hear more about them. So with that, Phil, I'm going to go ahead and turn it over to you, okay?
Thanks a lot, Alicia. And yeah, I'll just emphasize what Alicia said. You know, if you have questions at any point throughout the next hour we're going to spend together, put them in the chat box. I'm happy to address them. I don't even like hearing myself talk for an hour straight. And so anything that comes up, I mean, by all means, reach out. So today we're going to cover 4 different proposals and programs that were ultimately funded through the Concrete Masonry Checkoff program. And these 4 were kind of the first ones we'd submitted back when things began. So we had one on strength design of masonry, we had one on masonry specifications, one on Revit details, and one that was helping us with some research initiatives at the University of Louisville. So we'll go into a little bit of depth about all these programs, you know, where we're at as far as completion and kind of what the expected impact is. And as we talk about that, I mean, I like to put photos throughout my presentation, kind of highlighting the impact that we're looking to see out of these programs. And so in the background of this slide, we actually see Tri-County area schools. And this school is actually designed with another material. And this is a good example of a project we were able to convert to load-bearing concrete masonry construction, not only all the exterior walls, but all the interior walls and partitions as well. And so that's really what we're looking is driving market share out of these programs and growing the concrete masonry industry. Before I do get started as well, I did want to thank the Regional Advisory Committee in Region 3, where we're located. And specifically, I wanted to thank John Larandow. He's really done a great job. It's kind of coordinating and helping our region from a proposal standpoint. And so really appreciate all his help. And prior to Alicia starting, Jason Thompson was really involved with these contracts as well. So thank you to Alicia and Jason for helping coordinate all this through the Department of Commerce. So like I said, we're going to try to highlight projects and ways that we can showcase the value that our industry offers. And in regard to this picture we have in the background, it actually shows up on the front cover of the new Masonry Designer's Guide. And so I'll put in a little shameless plug for TMS and my friends over there, but the Masonry Designer's Guide was just released and it's based on the 2022 code that we just adopted 2 years ago, or I guess just published 2 years ago. The book itself weighs 6 pounds. It's huge, but it's a really good reference. And so if you work with architects or engineers or design of masonry buildings, head on over to TMS and grab a copy of this. I thought we'd go through the Region 3 proposals first, and then we can talk about our national proposal, which was funding that research at the University of Louisville. And so to start with our Region 3 proposals, I wanted to start with 0-41, which was our strength design of masonry proposal. So the original scope of this proposal included developing a new presentation specifically on strength design of masonry. And we did this deliberately for the 2024 annual CME conference, which CME is our Structural Engineers Association of Michigan. And we also helped fund another presentation, which was developed by Davenport Masonry, one of our larger mason contractors here in Michigan, on constructability of CME projects, which they also gave at that conference. After we kind of got the ball rolling on this, the scope expanded. And so through work with Mark Wilhelms, we were able to go down to the Structural Engineers Association of Kansas and Missouri, SECM, and give this presentation down there, as well as at the Minnesota Structural Engineers Association. And we have an upcoming one next week, actually, with the National Council of Structural Engineers Association, NCSEA. And I believe they have about 180 structural engineering companies already registered for that one next Wednesday. So if you're interested in that, I mean, you can definitely go to NCSEA's website and register for that. Additionally, we were just contacted actually by ASCE, the American Society of Civil Engineers down in New Orleans, to potentially speak on this topic at their annual conference in the fall, where they expect to have 600 or more attendees. And so a really good opportunity for us to kind of talk about masonry design and how we can design masonry structures economically. Background on this slide, so this is a Jiffy Mix manufacturing facility. So if you buy cornbread mix at the store, a lot of it comes from Jiffy Mix in Chelsea, Michigan. And again, this was a building that was originally designed using precast tilt-up concrete panels that we were able to switch to load-bearing concrete masonry. And I believe we actually saved 6 months on the schedule in doing so, as well as some budgetary savings as well. So just another really good example where you can kind of apply these principles and get people using structural concrete masonry on their projects. So as I mentioned, the original scope was for the 2024 annual CME conference, which was held back in May. We had about 120 to 150 structural engineers in attendance, and this year they actually expanded their annual conference to a 2-day event instead of a 1-day event as they had in the past. And so because of that, we were able to kind of talk with their leadership and get 5 specific masonry presentations. And so we basically covered one of their entire days for continuing education, which was awesome. So Tom Elliott with the International Masonry Institute, he was able to speak on the evolution of structural masonry. Scott Walkowitz presented on movement joints. I gave the strength design presentation that we developed. Scott gave another one about ways to save owners money. And lastly, Kyle Laconic with Davenport Masonry kind of talked about the contractor side of it and just how different details can have a significant impact on schedule, cost, all those other things that go into how projects get selected. In terms of the one I developed through the Concrete Masonry Checkoff program, it was on strength design. We're not going to go into a ton of depth on it because it was a full 1-hour webinar or presentation, but strength design is essentially one of our 2 main design methods that we have for designing masonry buildings. The other one is allowable stress design. And the reason that I focus mainly on strength design is because when undergraduate students take concrete or steel design, they're typically taught strength design. The concrete industry and their design standard, ACI 318, does not have allowable stress design in it anymore. And AISC, our steel design manual, actually, they kind of recalibrated allowable stress design, and so they mainly stick with strength design as well. So the only things we can really design with ASD would be wood and masonry, but since students are already familiar with strength design, that's what I teach at the college level, and that's what I wanted to help educate engineers on through this program. And strength design, I mean, very, very simply put, we basically take our loads and we factor our loads up, and we take our resistance or our capacity of our members and we factor that down. And so we make sure that all of our masonry walls, beams, columns all those members have sufficient capacity beyond the expected loads. And the reason for this is, as you know, we've been reviewing projects throughout the last 5 years I've been at the MIM. Things haven't been going great. I mean, these are some details off of a school project, in Michigan, where, some of the engineering decisions are made are really causing masonry to be a lot more expensive than it needs to be. And unfortunately, kind of the impact of this is we're seeing school districts and architects and engineers that historically have used masonry turn to other building materials because of the perception that masonry is too expensive. And so what we're really trying to do is educate people on how to efficiently design with masonry so that way we can be as cost competitive as we can be. But I mean, some of these details, I mean, are more common, in West Coast areas or areas that have a higher earthquake design load. But in Michigan and in most of our areas in Region 3, I mean, these, aren't necessary and do nothing to add cost and schedule the projects. So like I mentioned, I mean, most of Region 3, again, this was a regional proposal, so we can see here kind of on a map where Region 3 is. We're in a relatively low seismic area, so we're not subject to a lot of those same prescriptive requirements as some of our higher seismic areas, and we are allowed to use unreinforced masonry in a lot of these areas. The only area in Region 3 where we have larger kind of seismic design forces is near the New Madrid Fault, which we can see down here, kind of where that target is, and southern Illinois, southeast Missouri, and western part of Kentucky. And there we get in a pretty high earthquake hazard up to seismic design category D. So we kind of got to be careful about how we're designing and detailing masonry buildings in that area of the country. But Michigan, Minnesota, Wisconsin, Iowa, I mean, we're in a pretty low seismic zone up here. And so we can take advantage of that and design economical masonry structures throughout most of our region. That being said, we do get earthquakes in these areas. In my prior life, I had to actually look at some earthquake damage in Michigan, which was kind of odd. But we did have a 4.2 magnitude earthquake back in 2015 in Michigan. I remember feeling the aftershock where I was in Lansing, being kind of the original earthquake. And this building was located like pretty much right on top of where that epicenter was. And it was all unreinforced stacked bond fluted block built in the 1970s. And so they had actually some earthquake damage on a building in Michigan. And so we do have to make sure that we're taking that into consideration in our design. But again, our risk and our accelerations are much, much lower. And so some of the things we covered, and again, this is really brief just because, again, I mean, this is a full 1 hour presentation, but we went through a lot of discussion and recommendations for masonry partition walls. Again, this is an area we're really trying to target, especially through the MIM, because oftentimes when we look at square footage of walls on a project, partition walls are more than our exterior walls. And so if we lose the partition walls in buildings, schools, things like that, that's a lot of block that we're losing on those projects. So specifically in our lower seismic design categories, Michigan, Ohio, Indiana, those areas, we could use unreinforced masonry, or if we want to reinforce it, which we'll kind of talk about, we can actually space reinforcement up to 10 foot on center. And so we tried to educate engineers on where they can use this maximum spacing, how high the walls can be, things like that. We also tried to educate them on partition wall design. One of the biggest, not a big problem, but a problem that we frequently see is we'll have a partition wall that maybe spans to our roof deck and is built a concrete block, and we put these angles up to our roof deck and we weld them and then we bolt them to the top of that wall. Well, as soon as we do that, those are going to function as a shear wall. And so we want to be very careful about what we're intending to be participating and what we're intending to be kind of partition walls. And again, I'll do another shameless plug for TMS because this school, Byron Center Intermediate School, Consumers Concrete supplied the block on that, but that's on the cover of TMS's Masonry Design Guide as well. So what we did is we provided design tables to architects and engineers that basically told them what the minimum prescriptive requirements are depending on their seismic design category. And again, in seismic design categories A and B, we don't have any minimum prescriptive reinforcement requirements. And so unreinforced masonry is something that we can use in those areas. Once we get into C, we're looking at 10 foot on center. But we do have a full kind of partition guide that we developed, and we've been giving this out in lunch and learn presentations and things that kind of goes through all the code requirements, kind of where these things are coming from, general design practices, things of that nature. Because as much as we can, we're trying to make design of partition walls especially prescriptive. And so in here, we just kind of give some recommendations, as far as here's how high your walls can be, rebar at 10 foot, here's how far a one course lintel can go. Anything we can do to make this stuff more prescriptive so people aren't spending a ton of fee and time designing it helps us to really promote masonry being used on some of these interior walls and partitions. So we educated them on that, and then we gave them tables for how high they can design with unreinforced masonry. So if we're looking at a normal weight block unit, a type S masonry cement mortar, which is pretty common here in Michigan, if we are using 8-inch block, that can span vertically about 16 foot, unreinforced and ungrouted. And so for walls that are designed as interior partitions, I mean, mortar is important, unit density is important for anything spanning vertically. If we start to span our walls horizontally, which is commonly what we see in school construction, janitor closets, things like that, we can actually span quite a bit further. So if we're looking at, again, type S masonry cement, if we have an 8-inch block wall, we can go 20 foot horizontally. So that's where it becomes very economical for us to use even 6-inch block for some of these partitions. 6 inches attractive because if we already have 2x6 stud construction and we have a 1/2 inch of gypsum sheathing on each side, we're not losing square footage on our building by switching to a 6-inch concrete masonry unit. And so if we can make it work either unreinforced or minimally reinforced, it helps us kind of capture some of that market as far as interior walls and partitions. This project here, this was 12-inch block. This was actually an at-home retail building. They sell furniture, I believe it was 90,000 square foot. And that was, designed as precast tilt-up construction, and we were able to convert that to 12-inch load-bearing concrete masonry, single width construction actually as well. Yeah, and so really good opportunity for us to kind of use this stuff and actually push projects out there. In regard to that partition guide, which we will have up on our website, we just use that on a project during the bidding phase, and we're able to save about $90,000 just on partition wall reinforcement. That's all we looked at was how we can economize the partition walls in this school. I believe it was a elementary school, but because of the plan layout and everything, we're able to save $90,000 of taxpayer money and kind of show the school district how masonry can be economical. So we've been using this, we've been handing it out to architects and engineers, and more than anything, we've been getting involved on their projects and just answering calls on it. But for seismic design categories C and under, we kind of have some wall heights in here where as long as you fit these parameters, reinforcement at 10 foot on center, if we have control joints, we need a rebar on each side of it, jams of openings, things like that. We end up saving a lot of grout and a lot of reinforcement on projects, as well as the labor associated with that. And as sustainability becomes more and more of a talking point on projects, anywhere we can save on grout, we're saving on cement, we're increasing our sustainability of that wall system. And so we spent quite a bit of time talking about interior walls, partitions, ways we can kind of space out reinforcements, make walls more economical. We did spend some time on shear walls and exterior concrete masonry walls as well. And in Michigan, in most of Region 3, again, other than areas near that New Madrid Fault, we're in seismic design categories A, B, and C. And so our maximum prescriptive limit of reinforcement is 10 foot on center. And so, I mean, anywhere we can kind of push engineers to space that reinforcement out, not only does it help from, again, a rebar and grout savings perspective, but also from a labor perspective. One of the other reasons that I did want to present at CME, and this is something that's come up a lot on projects in the last 8 months or so, was engineers are using what they call a pier, which the definition isn't really in our TMS 402 anymore. But as soon as they're calling it a pier, they are designing it as a column. And a column made of masonry needs to have ties around it. And so what they're doing is they're putting all this rebar in the concrete masonry wall, and then they're having these lateral ties surround it. But masonry, just as a material, is very, very good in compression. And so we talked about how we can eliminate these ties and kind of save money on projects that way as well. And just, to put some dollars and cents to it, we had a gymnasium that got built in Michigan about a year ago. And we were able to save $110,000 just by getting rid of ties in the walls. The engineer had put lateral ties under all their rebar, every single joist bearing location. And working with them and the design team, we were able to kind of show, that we didn't need them. And this was after the project had already been awarded. And so that was the money that the mason contractor ultimately gave back to the owner in terms of a value engineering savings. But I mean, it's great to save money on masonry projects, and we sure like doing it. But the problem is, I mean, if we keep allowing this stuff in design, there's been several gymnasiums in Michigan that have used alternate materials other than concrete masonry just because of that cost. And, I mean, it's a whole discussion on real versus perceived cost, but we want to make sure we're designing our walls as efficiently as we can to really promote how concrete masonry can be used economically on these projects. Another thing that we wanted to tackle was just, a lot of times on drawings, we always see in Michigan, number 5 at 48 inches on center. Just kind of always been that way. We're trying to change that because, again, we are permitted to go up to 10 foot on center. But we talked about that a little bit in our presentation and just implications of going further apart. This is a 16-foot tall wall we looked at with them, and we only needed a bar at 64 inches on center. And so we're able to save kind of a grout space and rebar in every wall panel on that project. And the last thing we covered was masonry lintels. And so, I mean, here we're just trying to avoid stirrups and make sure people are using masonry lintels on their projects instead of steel lintels. Usually we deal with a lot of phone calls between kind of the fall and the spring with steel lintels that are getting welded on both sides of an opening. And then we're dealing with, drastic temperature changes in Michigan. And so we get some cracking and things associated with that. So we're really promoting masonry lintels. And if we're using masonry lintels, trying to avoid using stirrups. And so we boiled kind of everything down to them to a very simple equation. You just take your design shear force and divide it by a number. And these are the numbers for 6-inch, 8-inch, and 12-inch block. And this just gives you how deep that lintel needs to be. So you don't need stirrups. And so just a really quick, easy thing for engineers to check to see, number one, if concrete masonry is practical, depending on whatever the height is above our opening. Maybe it's not, but in many cases it is. And so once we know we have sufficient height, how deep does it need to be that we don't really need stirrups in it? One of the other takeaways I had from this was there seems to be massive confusion about CMU lintels versus bond beams, and that language kind of being used interchangeably. And in drawings, we all see this where they're showing this kind of closed bottom lintel unit, calling it a bond beam. And usually it's not an issue because a lot of our workforce and block producers are pretty educated on these things. But I have seen it be an issue on projects where, they're intending for one thing, calling it something else, and it being an issue. And so kind of to close this program out, I mean, I thought the presentation was really well received. I've had a few requests to come to offices and meet with them about this. And actually right about the time we were doing this, there was a wash bay facility down in southwestern Michigan that was designed as a wood frame structure. And so we were able to get involved on it and actually using this presentation, meet with an engineer and convert that to load bearing masonry. And in this case, it was a cavity wall with a concrete masonry veneer. And so it was about probably a 300,000-ish masonry budget on the project that we're able to realize. And it was solely because of kind of this presentation and what we were able to do with it. And so with that, I mean, I'll take a real brief pause, before we get to our other programs because we got 3 more to get through. But any questions about this first program? I mean, I'd say, we've completed all of our deliverables in terms of this program. Our scope kind of expanded to presenting at other structural engineering associations and got a lot of opportunities to kind of, take this forward as well. And so I'll pause for, 30 seconds or whatever. The rebar spacing on the wash bay job. So we elected to use 8-inch block, and I believe it was 20 foot to bearing. And so we were at 32 inches on center in on that particular project. If we would have used 12-inch block, we could have spaced it out further, but then it drove the labor cost up because of the weight of the 12-inch units. And so to stick with an 8-inch nominal unit and a CMU veneer, it required rebar at 32 inches on center. All right. So no other questions in the chat box or in the Q&A kind of thing, we will move on. But if you have any questions about this, I mean, we can certainly come back to it. But we'll move forward. So the next one I wanted to talk about was our proposal 37-23, and this covered masonry specifications. And the reason that I put this proposal in to begin with is we had a really good masonry spec that we developed through the MIM that we'd been kind of handing out to architects and working with them. But it was like 50 pages long, and it covered kind of the full gambit of masonry projects. And so I wanted something specific to all of our different wool assemblies. And so the scope of this program involves developing 7 new kind of pre-edited masonry specifications for all of our most common concrete masonry wool assemblies we kind of see in Michigan and in our region. And so we partnered with Amy Baker, who's an architect in the Detroit area who specializes in specification writing. And she was able to kind of go through and develop pre-edited masonry specifications for our most common concrete masonry wall assemblies. So we have one for unheated buildings using single white CMU. We have one for single white CMU with insulation, either on the inside face or wherever. We have one for insulated single white CMU, and so that would kind of encompass products like the high R and high RH from Concrete Products Group, things like that that are specifically made to prescriptively comply with the energy code. And then we have several for our cavity wall systems. So we have a CMU backup with a concrete veneer, which I just shared that with John Larandau because they're looking to get into the concrete brick market. CMU backup with brick veneer, CMU backup with brick and concrete veneer. We see that used a lot where maybe we'll have a water table with concrete masonry, and then we transition to a brick elsewhere up our elevation. And then we have one for a CMU backup with brick veneer and stone accents. And so partnering with Amy Baker, we got a lot of input on these specifications. And so we're still letting architects make all their material selections. But for instance, if they're designing a single white block building, we don't give them options for cavity because it doesn't exist in that building. And so I was working with an architect that did a lot of wastewater projects, pump stations, things like that. And they were getting confused about things that weren't even really in their wall assembly. And so I was able to give them the specification for a single white block wall and, walk through it with them. And now that's what they use on all their wastewater projects. And so, I mean, we're just trying to make sure that people are specifying our product correctly, to make sure that it's getting built correctly. And so we have been sharing these specs with architects throughout Michigan using lunch and learn presentations. They will eventually be uploaded to the MIM website as soon as I quit making excuses and just do it. And we'll have to undergo review within the Concrete Masonry Checkoff, but they'll be available in some way to people to use eventually as well. And like I mentioned, we've already seen these used on quite a few projects in Michigan. And just last week, I met with the architects that do all the prototype work for DFCU. And they were looking at specs kind of from Michigan all the way down through Florida for all those projects, which they are all concrete masonry backup walls with a brick veneer. And so we're able to use these new specs and kind of walk through it with them and make sure that they're specifying things correctly on those as well. Just a couple areas where we typically see issues in terms of specs. I mean, pre-installation meetings, pre-construction conferences, those aren't happening as often as I would like or our contractors would like. And I mean, this is really where we have an opportunity to clean things up before construction starts. Yeah, and so we give people an agenda for those. We really encourage them, especially in kind of the post-COVID world. We have a lot of opportunities to do these virtually through Zoom, whatever. But that's where we can really catch a lot of things. And so we have a lot of good language on that, as well as an agenda. Quality assurance. Testing is a major issue in Michigan in terms of grout and mortar testing. If you've never seen a pinwheel on a project, and so that's what we see over here on the left, that's not good. So there are ways that we're supposed to be testing grout and mortar. Oftentimes that's not being followed. And the problem is, by the time we realize there's an issue, a significant amount of masonry has been constructed. Here's some pictures and information. This was a stair tower up at Northern Michigan University, and grout broke bad, and the stair tower was already done. And so now what do we do? And so we were able to show that the grout wasn't tested correctly according to the ASTM. And we met with the construction manager, but the owner, Northern Michigan University, had a concern that, the mason contractor was using inadequate materials. And so they ended up pulling face shells off and I believe grouting solid the bottom 2 stories or so of this masonry shaft. But more than kind of that, it kind of just put a bad opinion in the owner's mind as far as concrete masonry. And so we want to make sure testing is done right. So we have a lot of language on that in our specification as far as what they're supposed to be doing. Mock-ups as well, and those sorts of things. I mean, there is no workmanship standard for masonry. We have tolerances in our specification, but really a mock-up is there to protect the architect, the owner, and the contractor. And so we really spend a lot of time talking with architects and contractors about mock-ups, making sure that they're included on projects, because really that's the only opportunity to address workmanship kind of before construction. I deal a lot with pictures that are taken, after the building's completed, oftentimes from 2 inches away from the wall, and people having issues with, joints, layout, things like that. But really a mock-up's the time where we can really address that. And so we really talk about that throughout our specs. And really where it's an issue, these 2 pictures, this is a school project that's a burnished block unit. And the problem is this wall is exposed on both sides. On the back side of this wall is a classroom. This is a sort of janitor's closet type area. And so when they laid the wall, they put their line on the classroom side. And so on the other side of this wall, everything looks great. But they kind of put this wall washing downdraft lighting in this janitor closet area. And, everything's in tolerance in these pictures, but how can we address this? And so we spend a lot of time talking about mock-ups and things like that, just because we want to make sure to set those expectations early. Fire rated assemblies. So we do have some language in here about the equivalent thickness method. I actually have to jump on a call after this webinar with a fire marshal because they're raising issue because we don't have UL rated assemblies. So that is something we deal with often, but mainly in Michigan and throughout most of our area. We demonstrate compliance with fire resistance ratings through our equivalent thickness method, which is the calculated procedure in our IBC. And so we talk about that in our specifications, just because a lot of our producers haven't undergone UL testing because they don't need to. And so we made sure to include that. And as far as CMU specifications, I would say I'm surprised, but I'm often not surprised how many times I see things like, type 1 moisture controlled block specified. Things that really haven't been around for 20 plus years. F prime M of 1500 PSI is another good example, but oftentimes these specs are recycled and you're really not taking a hard look at. And so that's mainly why I wanted to put this program together, was to make sure people are specifying concrete masonry correctly, make sure they're designing it correctly. So CMU specs definitely are included. Joint reinforcement, that continues to be an issue, at least in Michigan, with people specifying 3/16 inch joint reinforcements when it's not really necessary structurally, instead of 9-gauge reinforcements. And then we kind of run into some issues with tolerances on our bed joints. Yeah, so I mean, just things that we run into a lot, we wanted to capture in these specifications. And the last thing we really wanted to highlight too was control joints. So like I shared earlier on, I mean, Scott Walkowitz with Walkowitz Consulting Engineers presented on movement control as part of that CME conference. It's a note we see virtually on every project that says, put joints at 1.5 times the wall heights, or 20 foot on center, 25 foot on center, whatever that may be. But I've been involved on quite a few jobs where, maybe they had critical shear walls, weren't really great about communicating it on the drawings. And, a contractor put a control joint there because that's what we've always done. And so, I mean, if we're not clear in our drawings and our specs about where this stuff goes, it really leads to issues down the road. And so in our specs, I mean, it basically says, locate control joints where they're shown in the drawings. And if they're not shown in the drawings, request clarification from the architect or engineer. Because this is an area where, contractors a lot of times take that responsibility, and it's not always their responsibility to take. It's more of a design decision. And yeah, I mean, no more dangerous words than we've always done it that way. So we wanted to capture kind of a lot of the lessons learned we've had by looking at projects and just come out with a really good set of specifications that are generic. We don't tell you what type of flashing to use. You can still make all your material selections, but if you have a concrete masonry backup and a brick veneer, we have a spec for that. And so we'll work with architects on that, mainly through Zoom. We've had a lot of virtual meetings with architects where we can actually walk through it with them. And that's nice because then you can pull up all your references online, kind of show them why, we're recommending certain things. But these are done, I need to get them on our website, which I should do. I'll get those on our website this week, hopefully. They've already been used on quite a few projects. The feedback's been good from architects. And I mean, this is something where we can assist them virtually in person. And, I'd suggested John Lorando in our region as well. I mean, this seemed to me like a really good opportunity, maybe to engage a mason contractor, an architect, and a block producer to go through a spec and in 15 minutes or so, just discuss what matters. Why does it matter if you specify this density? What matters, what doesn't, how does it affect cost? It seemed like a really good way we could kind of communicate best practices as far as concrete masonry to specifiers. With that, I mean, I'll again take another 30, 40 seconds. Any questions about this particular program related to masonry specifications, I'd be happy to address now. And I'll just monitor the chat box for a minute here. No questions. That's either a really good thing or a really bad thing. All right. Moving on. So, yeah, Mark mentioned dealing with testing. Yeah, we just as a quick aside, since we're doing all right on time, we actually partnered with one of our good testing companies here in Michigan, and we did a big grout workshop 27 days ago. And so we looked at different ways we can test grout as far as pinwheels, cardboard boxes, and cylinders. We used it as a way we could educate all their people actually doing testing in the field. And I remember it was 27 days ago because we're going to break the grout samples tomorrow for the 28-day testing. And we got pictures and videos and content on all of that. And so we're going to develop basically a one-page sheet on grout testing, a one-page sheet on mortar testing, and we're going to distribute that to not only contractors, but also to construction managers and general contractors, since oftentimes they're the ones that deal with these issues. But we really want to make sure everyone, put it in the job trailer on the board, but we want to make sure people are testing things correctly because this can really, really derail projects. And so we should have all that content tomorrow, and we'll be just developing that through the Masonry Institute of Michigan. But if you want that, I mean, definitely reach out and I can provide that. 38. So this goes through Autodesk Revit details. And so what we were seeking to achieve with this program was converting a lot of the details we already kind of had available through the Masonry Institute into Revit format. And the issue is most of our masonry details were in AutoCAD format and PDF format. Some of them are in SketchUp. But a lot of our architects and engineers are predominantly using Revit for coming up with their construction documents. And so our details are being developed by Adam Hutchinson with the Northwest Concrete Masonry Association. And we did get additional funding for this effort from the Laborers Union Local 499 here in Michigan and the Masonry Institute of St. Louis. But my whole goal with this program was, things that occur on every project. So every job has specifications, every job has standard details. And so why not give them a standard detail for a concrete masonry control joint that they can just drag and drop in their drawings without converting AutoCAD and all those other things? Because the issue there is, I mean, if we have different line types, that just adds data to their model and slows it down. So my goal here was to develop standard details in the Revit standard line types and fonts. Adam's done a really good job with this, so kudos to him. And I just met with him last week, I think. So we're almost done with this. But I mean, just things as simple as special inspection schedules. I mean, they're in our code, they're in our specification, but how do people actually put them on their drawings? And so we developed tables for all this. I wish special inspections got done in Michigan. Unfortunately, they're not generally done. But providing these tools for people to be able to accurately specify and design with concrete masonry. Control joints. Yeah, the nice part about doing this as well is then we can link them to other information. And so back when I had started doing this before, I didn't have time to do it anymore, we were putting links to the CMHA tech notes. So here's a detail for a typical Michigan control joint. Hey, Mr. Engineer or Mrs. Engineer, go to this tech note. This is where it'll tell you the fire resistance rating. This tells you where they go. So I mean, these details really give us an opportunity not only for people to design with things correctly, but also to educate them on, why are we using this detail? And so that's what we're looking to do with these Revit details, is just make things easier for engineers so we don't constantly get the same details that have been used for the last 30 years. I will share personally, one of my old firms, we still had sticky backs. So that was essentially 8.5 by 11 sheet of paper with a detail on it. We'd put double-sided tape on it. We'd put it on our design drawings and scan it in. So I mean, engineers and architects don't have time to constantly be reinventing this stuff. And so as an industry, I think it's important for us to provide it to them. As far as where rebar goes, is it singly reinforced, double reinforced? If it's doubly reinforced, where does the rebar go? We can provide all that information to engineers to make their job easier to specify concrete masonry. This is a big one in Michigan, and much of the Midwest, where if we have an intersecting wall, oftentimes we'd rather the contractor install the mesh galvanized hardware cloth at that wall intersection instead of the strap anchors everyone's used to seeing. I mean, not only are these a safety issue, but again, it's just adding cost to our walls. And if we're not designing them as flanged shear walls, then we really shouldn't be specifying this anyways. Yet this is a detail that creeps up on virtually every job because there's just not thought put into it. And so this program was kind of developed to create this content to push out to engineers to make it easier for them to, again, specify concrete masonry. And again, I mean, all this stuff is going to be at least on the MIM website. We'll have to review it with Concrete Masonry Checkoff to see how we disseminate it. But once it's developed, I mean, reach out to me. I can certainly provide it. And yeah, so I mean, that's that program kind of in a nutshell. Again, that one's almost done. Adam's on the call. I just saw he put a comment in the chat box. But yeah, I think I'm excited about this. I think a lot of our engineers are happy that someone's willing to do this for them. Because again, I mean, they just don't have time to update these on every project. Any questions about Revit details? I guess before we get to our last program. All right. With that, we'll cover our last program. So we got about 15 minutes left together. So I'll cover that, and then we can address any questions at the end of it that haven't been previously answered throughout today's webinar. So the last one was actually a national proposal. The prior three were regional proposals. And this national proposal, the scope included assisting with some funding research. And this was for research done down at the University of Louisville related to internal bracing of masonry walls and conducted by Mr. Mark McGinley. And so the MIM kind of partnered with the International Masonry Institute, the IMI, to go out and solicit funding to get this done. We've been trying to get this done since, I believe, 2010. And so we got the bulk of the funding through the Block Foundation, the Masonry Institute of Iowa, Bricklayers and Allied Craft Workers Local 2 of Michigan, Wirebond, the Masonry Institute of St. Louis, the Mason Contractors Association, the Michigan Mason Contractors Association, the Mason Contractors Association of America, and the Arizona Masonry Council. So I wanted to thank them because, I mean, without them, we wouldn't have been able to get this done. So the special thank you to them. And we got to do something about all these acronyms within the masonry industry. But no, thank you to them. We were able to get it done. The research actually concluded last month. And on Monday of this week, I just got the final draft report from Mark. So that's all getting finalized now as well. But it all relates to internal wall bracing. And so I just have a couple brief slides on what internal wall bracing is, why is it important. So wall bracing is actually an OSHA requirement, and federally OSHA says anything over 8 foot has to be adequately braced to prevent overturning and collapse in terms of concrete masonry construction. It doesn't tell us how to brace it, just tells us it needs to be braced if it's over 8 foot in height. And so the Mason Contractors Association of America, they came up with this council for masonry wall bracing and developed a standard practice for bracing masonry walls under construction, which was last updated in December of 2012. And so what they came up with is bracing walls for kind of a wind speed of 40 miles an hour. If the wind gets to 35 miles an hour, that's where we evacuate people away from the wall and out of the restricted zone, because masonry has a lot of very good properties. It's a very, very heavy material that you don't want falling on you. And so all these provisions are there to promote job site safety. And in the MCAA standard practice, it talks about coming up with a bracing plan that is designed using acceptable engineering practices. And so what we see done a lot throughout our region is what we'll call internal wall bracing. And that's where we're using the grout and the rebar already in the wall to resist some of those wind loads that we see during construction. And so this is a major advantage to concrete masonry just as a building material, because if we're using other, like a tilt-up wall panel, for example, oftentimes those systems rely on external braces, which are not only costly, but they affect logistics on a job site, just with the square footage and area they take up. And so with masonry, oftentimes, if we're designing it for our full occupancy wind load, we have enough reinforcement and grout in that wall that we can resist that 40-mile-an-hour wind load during our construction period. The caveat is, and so, MCAA standard practice was from 2012. And back then they had, after 24 hours, we needed a splice length of 0.002 times our bar diameter times our stress in our reinforcement. And so prior to that time, that was 24,000 PSI. And so that equation mainly boiled down to 48 bar diameters, 0.002 times our 24,000. And so that's kind of a number that we've used for internal wall bracing in Michigan and throughout our region. The issue is, if we calculate our lap splices in accordance with our TMS 402 masonry code, if we look at a number 5 bar centered in an 8-inch block wall, for example, that comes out to 20 inches. Using our standard practice, if we had 48 bar diameters, which for bars smaller than a number 8, just becomes 6 times our bar size, it's 30 inches. And so this research was mainly to kind of harmonize these provisions and not have a longer lap splice required than what was necessary. If we don't need to be lifting block up and over lap splices further than we need to, obviously there's a labor component with that, especially in areas that don't have open end or double open end units. And so that's what this research was mainly aimed at doing. And so in terms of internal wall bracing, we already kind of talked about what the advantages are. Doesn't take up space with external braces, has that job site safety. And so we don't need dead men, augers, those sorts of things. And so real advantage to masonry construction, is that we don't need those things. We can rely on what's already out there to resist those wind loads during construction. And in Michigan, we're lucky enough to have Todd Daly here, who does the bulk of our wall bracing design for Mason contractors. And so, I'll give him a shameless plug here as well, but he has good design tables on his website. And if we look at, an 8-inch block wall, just with rebar at 4 foot on center, it can be internally braced up to about 18 foot, and so really good opportunity for us to leverage what's already been designed and avoid using external braces or making our wall system more expensive than it needs to be. And so all of our contractors use internal wall bracing for the most part, unless we get in a condition where we can't use it. This is a school that's getting built, by my house. And on this particular project at their gym walls, I forget what that wall height was. But Todd had to work with the engineer and with the contractor and add a little bit more reinforcement just in the bottom 4 foot or so of the wall to resist those wind loads during construction, because the engineer had spaced them out as far as they could, which was awesome, helped us reduce our cost as a masonry material. But we had to add a little bit more reinforcement there as well. This is my 3-year-old. I drag him around and talk to him nonstop about masonry. So he's either going to be an engineer, a home brewer, or I don't know, something else, but I'm pushing for those 2 things. All right, so the testing, like I said, it was done. So what they did is they built 6 foot tall masonry wall panels down in Louisville, along with assistance from the BAC down there. and they basically hooked up a hydraulic ram to it and pushed the wall over at different time intervals after grouting. And so here you can see kind of that in action. And so it's pushing on that. So it's loading this bar in flexural tension instead of direct tension, which is what the prior testing was done using. And then they looked at, how did it react? And most of the failures were kind of in the bed joints, as we can see. And, the draft findings were showing that 12 hours after grouting, if we used a high early cement in our grout, we're developing enough strength to yield that rebar. 24 hours, with a standard grout mix seemed to be getting us where we needed to be. And so I think there is opportunity here to, meet with MCAA and try to look at the standard practice and see if we can revise it based on this research to help limit those lapse places in our wools. Again, I mean, there's a huge labor component for it. To it. And the research, like I said, is completed. The final draft report was submitted on Monday. And so based on those results, we're going to be coordinating with MCAA and discussing how we can update the standard practice and encourage contractors to use those shorter lapse places while still maintaining safety during construction. And that way we don't have two different values for lapse places between our code and our standard practice. And so that's what that program's for. Again, the draft report is done Monday. And so this program's virtually completed as well. And then we kind of have some future steps as far as coordination and updating some of our standard practice information. And with that, that's kind of my 4 programs. So we got 8 minutes left together. And I'll address any questions you have on these 4 programs, on anything else you want to talk about. I'm here for you. So again, I mean, thank you to the Concrete Masonry Checkoff board, for ultimately approving these and helping out with the Department of Commerce. I think there's a lot of opportunity with these programs to really drive some market share. These programs were pretty low cost. I'm a frugal person, just the way I was raised. And so we tried to do as much as we could with as little money as we needed. But we're already seeing the results on this, and we are tracking how much money we're able to save on projects and jobs we're able to convert to concrete masonry. We're tracking that as well, just to kind of hopefully build, an inventory of things we can do to help increase our market share. My contact info is on the screen, my email and my cell phone. You're always more than free to reach out to me. And with that, I will turn it back over to Alicia. But if you have any questions, put them in the chat box. I'm happy to answer them.
Awesome. Well, thank you so much, Phil. This was very informative. Does anybody have any questions? Please put those either into the chat or the Q&A. I can check the Q&A, nothing there. And Phil's contact information is up on the screen there. So if you have any questions about any of this, I'm sure he's open to you emailing him directly. And certainly, if you need anything or have any questions, feel free to reach out to me as well. So hopefully this webinar was helpful to all of you out there. We truly appreciate you joining us. And so if there are no other questions, we can go ahead and wrap it up. We'll give it just a couple minutes here, but yeah.
I will comment on Demetrios's question real quick, if I may. So Demetrios is talking about importance of bracing during construction. And yeah, so in Michigan, we have had several tornadoes in the last year. I actually, experienced one of them firsthand with my 2-year-old at the time, which wasn't a great experience. But this was a project that was actually, this was constructed and then there was a lawsuit. And so it's mainly sat there for 8 months. 12-inch block project. And this took straight line winds of 100 and so miles an hour. And I mean, we can see that they grouted it, so that's good. But the interesting part, with wind and tornado damage is failure modes. Some of the rebar actually pulled out, even though they had enough lapse place length on this project. But some of it we found actually didn't even yield or neck. It actually ruptured. And so essentially the wind hit this wall with such force that it kind of took it from 0 stress to kind of its ultimate rupture strength. And so, yeah, wind is a scary, scary thing. I will share in Michigan, we are in the ICC 500 map as far as, providing tornado shelters for students in K through 12, but our legislature took it out in the 2015 Michigan Building Code, and we're currently adopting the 2021 Michigan Building Code, and the language on their website has that being taken out again. And so we're not requiring schools in Michigan to have storm shelters. As a dad, that's very alarming to me. But yeah, I mean, wind is a scary thing, Demetrius. So I'm there with you. But yeah, unfortunately, our legislature doesn't view it as such in Michigan.
We'll keep working on it, right?
Yeah. No, I mean, so yeah, we have been lobbying the government, through the Masonry Institute of Michigan and through other avenues to try to make sure that language is included. But yeah, we got a lot of work to do in terms of codes and standards.
Yeah. Great. Well, very good insight, Phil. We really appreciate it. It looks like everybody agrees. Great presentation, very informative, and will eventually grow market share for us. So thank you. I'll go ahead and wrap it up here if there is nothing else. Thank you, everybody. Have a wonderful day. You're free to go for the rest of the day. Please join us. Look for the next webinar, which will be late July, where we'll share with you what Clutch is working on. So have a great day. Thank you, Phil. Thank you, Aaron. And I'm going to go ahead and end the webinar. Thanks, everybody.
Thank you so much.
Thank you.